Hey everyone! So today we'll be learning about PCG. Now what is PCG? It is Procedural Content Generation inside Unreal Engine 5. It is so handy and so useful because you can literally create huge environments. And when I say environments, these environments are dynamically created, which means later if you wish to change certain things in your environment with just a few clicks, you'll be able to achieve a whole new environment altogether. By the end of the video, you'll be able to achieve something like this. And I will show you how you can set it up the plugin, how to use the plugin itself, how to change the parameters, how to set the whole graph, and I will also try to make it easy because this is a long tutorial. So stay tuned and don't miss anything. So for this example, I'm using the Stylus Fantasy Village from this pack, and I just added it to my project right here. Now let's go ahead and set up our PCG plugin. To do that, go to the edit and then, go to the plugins folder right here and type PCG and make sure you turn both this checkbox on, and it will ask you to restart your engine. But before you do that, we need to also make sure that we also have the water plugin enabled. So just go here and just type water and make sure these two boxes are also turned on. And once that's done, just restart your engine and you should be good. Now the next step is basically creating our landscape. You can do it in a couple of ways. Either you can use the default Unreal sculpt your own landscape option, or you can import a height map from a 3D terrain generation software like Gaia, which I love a lot. But for this example, I sculpted my own landscape. So as you can see, I am just using the sculpt options which are already available inside Unreal Engine 5. Now, once I'm happy, the next step is basically adding a water body to my level. So to do that, just head over to the add quickly icon, which is right this one, and type lake. So I'm gonna type lake right there and just click and drag it to your level. And you can shape, this is basically a BP spline, which you can shape it to whatever, whatever shape you want. So I'm just gonna be tweaking this quickly here. I'm also gonna be adding a river in the similar way. The next step is creating a landscape material. You can use the default material which are already present once you had added the pack to your project, but I created my own because I wanted to tweak a few things. So I just created my own master landscape material and then created an instance of that. So that instances are, by the way, super useful because you need to have less master materials than the instances, because it will take or have more draw calls every time if you have more unique master materials. And the next thing is applying your material to your landscape. So just drag and drop the material over your landscape material, and then now we're going to be painting. So to do that, go and choose your paint mode under landscape mode, and then scroll all the way down where it says layers. We need to create layer infos before we can start painting. So to do that, click on the last icon which says create layer from assigned materials. So if you click on that, you should be able to see all the materials that you used to create the master material. So right now I have both of them, so I'll be choosing it, and now I'll choose any of the materials, it doesn't matter, but I'll be using the grass material, and then I use my paint option and I simply go ahead and paint the entire environment. It will look a little bit weird at the start, but don't worry, just cover the whole environment with any one of the material that you like, because later on we'll be blending, like I said, the two materials together. So just to keep my PCG graphs separate from the ones I already have, I just went ahead and created a new folder for PCG, and I named it PCG Fantasy Village. There you go. And then let's just create our first PCG spline. So sorry, BP spline. So right click and choose a blueprint class and choose an actor. And I'll just name it BP underscore a village. And this next thing, what we want is a PCG graph. To do that, just right click and then head over to the PCG. There you go, and choose the PCG graph. I'm gonna name this one as PCG underscore fantasy village. And now just double click on the BP spline for now. So I'm just go ahead and save this and then click on the BP spline. And now we need to add a spline component. To do that, click on the add button right here and go and type spline and search for a spline. Don't select the spline mesh, it's just the spline. And a spline should pop up in your viewport. And now we're gonna do is select the next point and increase the location to around something around 3000. 3000 right here. The reason why we are doing this is because once we drop it in their level, this spline would be easily visible. That's the reason why. Compile it, and the next thing we're going to do is select the scene component, the top component, and under the details panel right here, we're going to look for tags. Now, this tag is super important, so I'm going to just name it as village. The reason why we are naming this spline and giving it a tag is because once we want to call this BP spline inside our PCG graph, it needs to know which spline the graph needs to look at. That's why tags are super important. Hit compile and hit save. Once that's done, now we're gonna open our PCG graph. But before that, we need to drag and drop the BP spline inside our level. And let me just give it a, something. Let me drag the points and create some random lines, basically going across the lake what we already have. Or let me just tweak it a bit here, probably there. And all I'm doing is to add extra point is create a point, click Alt and drag the point so you'll be able to add more points. That's what I'm doing. And once that's done, and once you're happy, yeah, I'm quite happy with that. So I'm gonna save it and first drag and drop the PCG graph inside level and make sure that the PCG box is covering your entire landscape. So let me just quickly drag this and scale it all the way so that it's covering the entire landscape what we have to something like that. This is super important because if you don't do it, the points or the PCG graph would only and only work in the areas which are inside the box. So let's just open our PCG graph. So once inside your PCG graph, first thing we need to do is right click and look for get actor data. So what this does is basically this node would look for any actor data inside the level, let it be a spline or let it be any actor inside your level. So under the actor filter, we're gonna use it by all actors because it needs to know, it needs to calculate all the actors because right now we also have our lake spline inside it. So we need to make sure it's looking for all the actors. But this is where the tags come in very handy because as you can see under the tag option, actor selection, we have either by class or tag. We will be using by actor tag, and let's go and choose the village tag, which we used it for our BP spline. And now the actor data knows which spline to look at, and we'll drag a point out from the actor data and look for spline sampler. There you go. The reason why we're using a spline sampler is because we used a BP spline inside our level, and that's why we need to use a spline sampler. This will spawn points all the way along the spline. And at start, it's going to be super hard to see. You'll see it why. As you can see now, we don't see any points because they are spawned, and to make the points visible, we're going to be using a bounds modifier. So let me just go ahead and use a bounds modifier. So let me first increase the min and max bounds of this. And if you see, we still don't see any points. The reason why is because we need to debug these nodes. And if you see, we have a debug option. You can also use the shortcut D, but if you do that, now you'll be able to see the points that are actually spawning on the spline. So if you choose and if you increase the bounds, or if you increase the bounds, you'll be able to see it more clearly like this, and it is all spawned along the points. So now let me just hit D again to get rid of the debug and use a static spawner, because what a static spawner is going to do, it's going to spawn static meshes all over on the points that are actually spawned. So let's just go under mesh entities and choose our first mesh under static mesh, so which is gonna be the meshes from our pack. So let me just go here and go under content browser under static under stylized village, and I'm using a static mesh filter. So I'm gonna go for houses, and let me just go ahead and choose one of these houses. There you go, and let me put it right here. So as you can see, now our spline is using all the points and spawning the meshes all over the points that were spawned before. So I know it might be a little confusing, but please bear with me, and will get super easy. Now what I'm doing is I'm gonna add all these options of houses that I already have, so just to create more variety. So let me just go ahead quickly and add all the houses that I want it to spawn, because more the houses, it will create more varieties for you. So as you can see, as I'm moving the spline, it is changing its changing the mesh based on the list that we gave it. How cool is that? So it doesn't matter where you place it, but it's gonna change. Now let's say if you want your houses to be spawned on the left and the right side of the spline. So to do that, we're going to be using a transform points node and offset the value from there. So let me just go ahead and debug this quickly by pressing D. And oh, there you go, like that. And then I'll scroll all the way up where it says offset min, and under the y-axis, which is on the center one, I'll use let's say minus 12. No, let's just do plus 1200. And as you can see, it changed its position. Let me do also on the max value. Now it has moved the points to the plus value of 1200 on the y-axis. Now let's just do something similar to this and spawn our houses on the right side as well, right here. So to do that, we're gonna connect another transform points, and this time we'll be just using a negative value. So let's just do negative 1200, negative 1200 rear. Now we have houses on this side as well. Now if I debug both, now you can see we have houses spawning on left and on the right as well. This is super handy when you want to create a path going through your village. So let me just connect it to a static spawner right here. Now, as you can see, now we are having houses that are spawned on left and the right side of the spline, because initially what we had was they were spawning on the spline. Now they are on the right and the left hand side. So let me just go ahead and select my spline sampler here. And now the next thing we're gonna do is under the mode option, where it says subdivision, we're gonna do it by distance. The reason why doing this is because now we can also adjust the spacing between the two houses. So as you can see, I'm increasing the distance increment here. The spacing or the spacing between the houses is increasing, and also it helps us to decide how many houses do we want it to spawn. So there you go. And now, as you can see, we have some problem here, which is basically they are too close to each other and they look quite repetitive. So what I'm gonna do is add a random choice. Oh, sorry, I'll do a select points first. And now I'm gonna tell the graph to select a ratio between, let's just say, 0.9 or so. Now it's basically calculating or taking only certain points from that particular place. Now This is why it's super handy when it comes to creating variations. Now we have more varieties and it doesn't look repetitive as well. So we can also play around with the seed value to add different varieties, and this is how easily you can change the layout. If I increase the ratio here, it will spawn more houses, and if I decrease the ratio, it will spawn less houses. Like this. To add more variety, I played around with it for a while to add more variations, and to basically break the repetition, I also added a rotation to the houses, so that they are not facing the same direction every time. By the way, this is all done inside the transform points node. I use the transform points node to rotate it, and now as you can see we have properly distant houses. Now we're going to go ahead and add some trees. To do that, I'm going to go and get a landscape data. Now what a landscape data does is basically it calculates the entire, let me just go here. Yeah, what a landscape data does is it calculates the bumps, the heights, the erosion, and basically anything that has to do with the landscape sculpting or height map. And this is where the entire data is stored. So if we drag out from here and use, let's just say, a surface sampler, for example, it's gonna spawn points based on the surface of our landscape, which is the height data. Oh, let me go here and debug this quickly. Now you can see this number of points that are spawning on the entire landscape. It is calculating basically all the bumps and the heights of this landscape and spawning points based on that. So now what I'm gonna do is drag out from the sampler and use a density filter. Now what a density filter does, it's basically takes the lower bound and the upper bound value, and it decreases and increases the number of points based on that. So the lower the value, it will spawn more points, and the higher the value, it will spawn less points. So this is definitely super useful for increasing and decreasing the density. Now the next step is I'll be adding a static mesh spawner and add some trees to it. So I'm gonna go and under the mesh entities right here, I'll click on the plus button like I did for the houses, and under the index value, let me just go ahead and select a few more. Yeah, under the index value, and I'm gonna go and look for trees, and let me just go ahead and select one of the trees here and click on this arrow, and now you can see the trees are basically spawning on all the points that we have. Now as you can see, it's too much clustered, so I went ahead and used the density and the transform points to add more varieties and add change the direction and also change the scale. So now what this has is the trees are basically spawning in different directions. Not only that, I gave it a ratio of certain values so that the trees scale between those two values. And the last thing what I also did is reduce the density because it was too much clustered. Once everything is done, once you're happy with how the setup you have right here, the next thing what we want is, I don't want any trees to be spawned in the path. So what I need to do is remove the trees which are spawning on the path. So let me just go ahead and first put this into a section called trees right here. Always make sure to keep things organized because that's super important. So there you go, I have kept all my trees. And now what we're gonna do is we're gonna use a difference node. Now what a difference node does is it's gonna take the points from my actual houses and my path where I have basically my houses spawned, and we're gonna tell it that, hey, remove the trees from these particular points. I don't want any trees to be spawning on these particular points. That's why we're gonna be using the difference node. So let me just go ahead and drag this here, and we're gonna tell this that, hey, you know, any points like these two, we're gonna be removing it. So to do that, let me just use a difference node right here. And now the source is gonna be our trees, because we want to tell it like, hey, spawn my trees only on these points, and the differences is basically difference all the points from my path and my houses. So, and under the density function, make sure it's binary, because if it's not binary, it will still try to consider few trees which are which falls under a particular value. So we're gonna tell it that, hey, either use 1, which is yes, we have trees, or 0, we don't have trees. So that's why we need to choose binary. And then once you're happy with that, let me just go ahead and quickly connect this with our static mesh spawner right here. So now the trees are not spawning anywhere near our houses, but we still have some problem here. We still have few trees spawning on the path, and not only that, we still have trees that are going through our houses. So let's just quickly change that. So the next thing we're gonna do is we're gonna also ask the difference node to consider a path. So let me just go and use a transform node, and now we're gonna not change any offset value, because if you remember, for the first two we did change the offset value because we wanted our houses to be spawned on left and right, and using this transform points as well to our difference node. Now if you see, let me just go, yeah, now if you see, we don't have any trees spawning on the path, and the path is totally clear with any trees. Now we also have some trees which are spawning inside the lake. So to also avoid that, as you might have probably guessed, we'll be using a get spline data, and we can also use actors, but we are using a spline data for this example, and just so that you are more familiar with few more nodes. And now what we're gonna tell the spline is, hey, consider all the points which are inside the spline. So let's just go ahead and first choose it and make sure we have all actors, and under tagged we're gonna use blueprint class this time. Now remember, last time what we did is we went with the tag, but this time what we're gonna tell it that, hey, use a particular class and only look for that particular class inside my level. So that's what I did, and I went ahead and I looked for the lake water body like that, and now it knows what to look at. And what we're gonna say is, hey, drag out of this and use a spline sampler, and once you have selected your spline sampler, the next step we're gonna do is we're gonna ask it to consider only the points inside. So that's why we go under dimension and choose interior. Now what this does is it's gonna consider all the points which are inside that particular spline. As you can see, we have this white portion. These are all the points that are spawned inside that particular spline. So now, as you might have guessed it, we need another difference node to remove all the points which are basically inside our lake. So let me just go ahead and look for a difference node, and then you can connect the source to the one coming out from the difference node for the trees, and make sure even that one is set to the binary. And now use and connect the spline sampler from the lake to our difference section, and then just disconnect our trees. And let me just go ahead and look for, let me just debug this. As you can see, we still have few points which are basically spawning beneath the lake. So we need to also ask the graph to calculate those points. So since we are using a spline sampler, this would be difficult to do, but what we're gonna do is add a different node. It's called the projection node. the projection node, what it does is basically it will project any points based on the landscape data. So that's why I've used the projection node, and it's going to project and consider the landscape here as a projection target, and our basically spline as our main target. So let's just go and plug it in this and use the projection as our landscape data now. And now, before spawning the spline sampler points, we're gonna disconnect this and connect it from the projection. Now, if I go ahead and debug it, you should be able to see that it has considered any points beneath the lake as well. Let me just go ahead and go here, click on the difference, and now there you go. We have a clean, nice lake without any trees spawning inside. Let me just undebug this and then disconnect this one, connect this difference to this, and then spawn our trees. Now, as you can see, we don't have any trees spawning inside our lake, which is exactly what we want. We would like the same to happen with our river as well. So let me just go ahead and do the same. So basically, I'm all doing is getting a spline data, connecting it to a different projection node using the same landscape data, trying to reuse some nodes and using a different node, and connecting it to our static mesh spawner to eliminate any trees spawning inside our river. So let me just go ahead and do a water body, and let me just go ahead and change the color of this as well. There you go, nice and sweet. Everything is organized quite properly. Now, taking a bit further, I mean, you maybe or may not want to do this, but depends upon your use. But what I'm going to do is I want my houses to also not be spawned on any water body. So to do that, all I'm going to do is basically use a difference node and take these 2 points right here and tell it to eliminate any house spawning on those particular points. So I'm going to use a difference node right here, connect it to our left and right source. So let me just go and plug it to those. Basically any these are the locations where our house are actually spawning. So I've just selected the oops, let me just take the path as well. Maybe, yeah, I'll consider the points first. So let me just take the points where I have my houses spawned right there, and then let me just do a density function to binary, and then let me just go ahead, use the difference, disconnect these 2 right here, and then connect it. Wait, I still need to connect the points from my water body. So I'm taking the spline sampler points spawning from each section here, just trying to organize it a bit, and also dragging, there you go, and keep this as well organized. And once that's done, nice and sweet like that. And now what I'm gonna do is basically, oops, I didn't want it to move that. Oh, give me a bit. There you go, yeah. And now all I want is to debug this first before I do it. There you go, debug this, avoid any water bodies so it's not gonna overlap with the water stream. And then lastly, I'm gonna connect it to my static mesh spawner like that. There you go. Now the next step is adding grass. So let me just go ahead and take the get landscape data. You can reuse this, but you know, I just like to keep it separate so that I'm not making a huge jungle of nodes here. So noodles here. So using a surface sampler as before. Now I'm gonna look for something called static mesh spawner because we want to spawn grass on these points. So going ahead and now searching for my grass static meshes. There you go. And I'm gonna choose a few of them. So let me just go ahead and plug it to all the static meshes. There you go, all of these. That's right there. So now that you can see, we have grass spawning on those particular points, but the density is not correct. So to increase the number of grasses or the density of the grasses, what I'm going to do is use a transform node quickly, and then change the scale of. I'm going to give it a ratio of min and max to 1:1.5, and now connect it to it, but still the density is quite less. So let me just go ahead and click on the surface sampler here. So let me just go ahead and click on the surface sampler. And now what I'm going to do is change the point extents. As you can see, each block has a particular size. So by changing the point extents or reducing the point extent in our case, it's gonna add more points. So let me just make it more dense by increasing the points per scale squared meter. Now you can see we have a lot of points spawning. And if I remove the debug option, now you can see we have grass field all over our landscape. I know it's also considering the water stream, but you know exactly what we're going to do is remove the points using a difference node. So let's just go ahead and remove the unwanted grass. So I'm going to use a difference node here, and I'm going to connect the source to the source coming from the grass, and then what we wish to remove, or which part we don't want the grass to be, is the water lake. So we're gonna I'm gonna keep it organized. I'm gonna take the spline from the lake and also from the water stream, and make sure this is set to binary again. And now disconnect the static mesh here, and then connect it from the difference node. And now if you see, it should have eliminated, there you go. Now if you see, it has eliminated a few of them at least from the main water stream where we had. We can tweak it more further, and it's basically by using a bounds modifier, but as you can see, we have none spawning inside our lake, which is exactly what we want, and we have a certain at the surface, which is not that bad, doesn't look that bad. So but just saying it, that we can actually eliminate that as well if you want. So let me just go ahead and organize this and name it grass and change it to something green. There you go. Now we're going to be adding more plants to this. So let's just go ahead and use another surface sampler this time, because we're going to be just using this landscape data. So to drag out from there and use a surface sampler. And now we're going to use a transform points from this one, and we can also change the same min and max, but also give it a rotation of 360, so that the plants are randomly rotating between the value of 0 and 360. Drag out from our surface sampler this time and use a density filter, like how we used for our houses. This is gonna decide how dense our other plants or bushes are gonna be. So let me just go ahead and quickly debug the density filter here. And yeah, as you can see, we have certain bushes, but I think there are a bit more. Yeah, there are certain which are also overlapping with the trees, which are fine, to be honest. I won't mind actually having that. So I'm gonna go ahead and increase the lower bound right here, as you can see, to reduce the density. And now I'm quite happy with how it looks. So yeah, I'm gonna go ahead and connect a static mesh spawner from our mesh transform points, and select our other plants, which are our bushes. So I'll be selecting, I'll select this one. Yeah, I'll select both this one, and next one would be, let's just say this one. Yeah, I don't want the one with the flowers. So there you go. I'll just go ahead and delete the slot. And now, as you can, if I save, now you should be able to see our bushes spawning on those particular points. So let me just go ahead and change the seed value and play around with some different variation. And yeah, kind of happy with that. Let me just change the scale. Let me just do 1.2 or something. 1.5 should be fine. Yeah. So 1.5, and now I am quite happy with how the trees are, the bushes are spawning. Let me just go ahead and save it. But as you can see, we have certain bushes which are also spawning on the lake. So as you know, what we're gonna do is again, remove those points. So we're gonna use a difference node again. So let me just go ahead and connect it to our, oops, there you go. Yeah, we need to connect it to that. So let's just remove unwanted grass. Let's just go and choose a difference node. And now connect the source to our plants. But before that, let's connect the lake points to the difference and then connect it to the source. Change the density function to binary, disconnect this, and then connect the output to our static mesh. And let me just drag this and let me just rename this. Oops. Yeah, let me just rename this as grasses and bushes. There we go. Save it. And now we have successfully eliminated any bushes spawning on our river. But we have some bushes spawning in our path, so I might actually also try to eliminate that as well. So let me just go ahead and do that quickly. So let me just drag this out and use another difference node from here. So let me just go ahead and take a difference node and make sure, oops, let me just expand this as well, connect this, and by selecting this, let me just go ahead, change it to binary again. And now what I'm going to do is go ahead and choose only the path this time, and then drag the point from there and connect it to my difference. Just trying to keep everything organized here. And now select the output from the difference to my static spawner. Now we have eliminated the bushes from the path as well. Now our next step is painting the path. So for that, first we need to select our PCG volume here. So once we have selected the PCG volume, just make sure you scroll all the way down under details and choose the PCG component. And from the PCG component, if you scroll down all the way to where it says input type, right here, where it says input type, and from the drop down, you choose landscape. This is super important because now we are gonna use a different node which is attribute. It's gonna look for the attribute inside your landscape data, and you'll see what it does. So we'll drag out and we'll say surface sampler first. So what if there's a situation where you want to spawn these points only and only in a particular place where you have your certain landscape property? Whereas when I say landscape property or landscape layers is mean like this one. So if I start painting dirt, let me just go ahead and unview, and let me just quickly start painting some dirt path here. All I'm doing is basically how you painted the grass path initially. This is exactly the same, but this time I'm painting the dirt patch. This is exactly what we spoke about, the landscape blending materials. So once you have painted, let me just go back to the selection mode. And now I'm gonna drag out from the surface sampler and look for attribute filter. Under the attribute filter, we need to make sure first we hit the use constant threshold and put a random value of 0.6 or so. And then we're gonna target attribute. It needs to be dirt. We need to make sure that we type the exact attribute name what we had in our layers, or else the attribute layer won't be able to find it. Sorry, the attribute filter won't be able to find it. So once you have done that, you drag and drop either from the inside filter or from the outside. Now what this does is basically it will you can either choose the points which are inside the dirt patch that you just painted, or select anything which is outside the dirt path. This basically works as a mask. So let's just go ahead and choose either the inside filter. So let me just go ahead and drag and choose a transform point to show you what I was talking about. Now, as you can see, if I debug this, it only considers the points which are inside the dirt. And now if I do outside, it will only consider the points which are outside the dirt patch. This is exactly masking. So for this example, we're going to be using our inside path. And now let's just say if I want some stones to be spawned on my path. So for that, let me just go ahead and drag. Oops, there you go. Let me just go ahead and drag a static mesh spawner, and under the static mesh spawner, all I'm gonna have is look for the mesh entries, and there you go. And this time I'm gonna look for rocks, and let me just choose this one and choose there. There you go. Now we have rocks only and only spawning on our dirt path. So to break the repetition, I'm gonna add a random rotation value of 0 to 360, and then also change the scale between let's just say 0.6 to 0. Probably 8. Yeah, I don't want the rocks to be too huge. So there you go. But as you can see, we have a lot of rocks spawning, and I don't want that. So let's change the density. So to do that, I'm going to use something called density filter. And now let me just break this, and then yeah, this is good. Let me just increase the value to reduce the number of rocks spawned. Oops, not that much. Yeah, this is good. And now let me just connect it to the static mesh. And yeah, I'm quite happy with the number of rocks that are spawned. So now the next step is basically, let's just say I want to eliminate any grass which is spawning inside the path. I don't want that. So we're gonna select the grass, go and make sure that we are inside the grass section right here. And now what we're gonna do is add a difference node, like you might have guessed it. But what we're gonna do is use the filter option. So let's just go ahead and look for a difference node right here. Oh, let me just increase the grass section here, and even the static mesh spawner. Perfect. Okay, now let's just take the difference node and connect it to the source, and let's add a bounce modifier right after our attribute filter node, and then make sure that we use the bounce modifier to extend the bounds of the points that are spawned, like here, 2, 2, or maybe I might also increase it a bit more. Yeah, because we want to eliminate any grass which is spawning inside that. So that's why I want to cover the entire path width with the bounce modifier, so that I can eliminate that particular area altogether. Maybe that's a little too much, but let's get started with that. So let me just connect this from the inside filter to my bounce, and from bounce to my difference node right here. And as you can see, now the grass has been completely eliminated from that particular bounce. So let me just go and decrease the scale of this. Yeah, a bit more probably. Let me play around this. Yeah, that's not too bad. But I also want the grass to be appearing on certain green areas. So let me just go ahead and decrease it further. And maybe furthermore. Yeah, that's not bad actually. Yeah, let me just decrease this as well. And this one too. Yeah, I kind of like how it is going. I'm gonna go ahead and save this. Um, let's choose a difference node and now connect it to our grass. There you go. And now you can see is connect this, add a difference node for my bushes separately, because with grasses it didn't work, and like I mentioned, it's always better to have separate difference node every time for each element you want to eliminate from your graphs. So I'm just gonna go ahead and I started painting some path throughout the entire landscape. Now the next step is basically scattering some random props inside our level. So what I did is I dragged out from my landscape data and used a surface sampler to scatter some points over my landscape. But this time it's going to be different, because what I'm going to ask the graph to do is basically scatter these points only and only around my houses. The reason why is because these props are going to be either barrels or, some random boxes, wine barrels, or even cart, the pulling carts or such. And I don't want it to be scattered throughout the environment. Or I don't want it to be scattered inside the lake or so. I only and only want it to be around the houses, but without it being colliding with my houses. So that's why we need to use the bounding shape right here. So that's why I went ahead and either used the points from one side of the spline. Yeah, right click and let me look for, oops, bounding box, bound modifier. Yeah, and what happens if I change the, let me debug this. Yeah, let me change the bound scale here to something like that. Probably that's a bit more, 10 by 10. Yeah, that's about the right shape as the bounding shape. And let me see if I debug this, what happens. Perfect, this is exactly what I want. So let me just go and quickly drag out from this guy. Actually don't need that. Yeah, let me just go ahead and delete this. So from the attribute noise, what I'm gonna do is connect this to our, let me just connect everything else and see where the points are spawning. Yeah, the points are spawning quite well, but we still have some points that are basically going through my mesh. So we're gonna do a difference node again, and then this time we're gonna say that, change this to binary first. We took the static spawner and connected to our differences, and now what we gonna do is use a bounds so that we should be able to, yeah, take the scale in consideration of the houses so that we can spawn basically how close the props you want to the house. There you go. Now these are our props. As you can see, these are all spawning away from the houses but near the houses. So let me just go ahead and change the bounds. Yeah, there you go. The lower the bounds, it's gonna spawn closer to the house. So let me just go ahead and do this and do that. That's quite nice. And now the next step is basically to add more randomization to this. So drag in difference node again, but before that, let's just remove anything that is spawning on the path. We don't want that. So we just go ahead and drag out from our, oops, from that and connect it to our, yeah, there you go. We eliminated all the points that are spawning on our path so that our path is clear. And now the last thing what we want is drag out from our grasses as well, because we don't want anything to be spawned on the grasses or inside the grass. And then also we don't want anything it to be spawned inside our water bodies. So that's our water body. Let me just go ahead and drag out from the lake first, and also our river. And let's keep things a bit organized right here. Perfect. Now things are more organized. There you go. We eliminated any props that are spawning inside the lake, on our path, on our houses. Perfect. This is exactly what we want. Now let's just repeat the same steps for the other side as well, because we want the props to be spawned on both the sides, right? So let's just do that. Copy and paste probably, because I don't think so the single data would work. So let me just arrange this first here. And then let's just go ahead and make some space. Yeah, copy paste, and let's just make some space for us. Oops. Yeah, let me select everything and move. Oops. Let me select everything and move it down right there so that we create more space. And now use the bounds. Use the bounds modifier for the other side as well. So the points from the other side of the spline. And to add more variation this time, what I'm gonna do is connect it to the same attribute noise and connect it to our landscape data. Perfect. Nice and sweet. And now let's just see. Perfect. We are spawning the props on both the sides. Now without wasting more time, let's add the last part, which is randomizing transform points first. And let's just add some rotation to 360. Scale is okay. I'm gonna drag out from the transform and look for something which says random choice. So what a random choice does is basically it will consider any 5 or 6 props from your static spawner and only spawn those props. So it's basically a random choice. It might take any props from those list of props you have. So you can choose how many fixed number of props you want to have from that list. So I'm gonna do 5 for myself. It selects those particular props and whichever props are discarded. I'm gonna use the select points and set it and give it a range and add all the list of props to the static mesh spawner. And there you go. We have a nice environment with random props created which are near the houses. We have a nice path. We have stones on the path, and we have grass field all over the landscape with these randomly generated and placed props in our environment. How cool is that? This is perfect. Looks great. So in addition to this, I added more lake rocks around my lake. I use exactly the same nodes that I used to scatter props around my environment, and use the transform points node to rotate the rocks and change the scale of the rocks, and also have a different ratio of scale. Now the last part of our graph, we have a nice setup right here, but the last and the few additions here and there to make it more realistic is adding a fence to few of the houses. And let me just quickly show you how to do that, because this is just an additional knowledge that you will be having. So just head over to the perspective view and head to the top view right here, and then from the selection mode right here, I'm gonna go and select modeling this time. Now, with this modeling tools, click on Draw Spline option, and then make sure that World Objects is turned off right here, and then just draw a spline with 1 or 2 points, or maybe actually three points here, to something like that, and click on accept. Once that you have created your spline, under your spline, let me just rename this first quickly to fence spline. And once you select the spline, under the details section, go and look for, under fence spline, look for tags, and under actor tags, make sure you add a tag and call it spline. This is exactly like how we did for the BP spline at the start of the tutorial. And now head back to the perspective view, and now take it to a place where I can see it properly, view it more clearly around one of the houses. Let me just take it out here, this side. Yeah. So once that's done, the next thing I'm going to do is go back to my PCG graph, and let me just first actually name, and let me just go here and quickly organize this, Lake Rocks. And now I'm going to go and look for get spline data, because we just added a spline inside our level. And now I'm going to, under actor filter from self, it's going to be all actors, and by tag we're going to use the fence tag here, and then drag out from it and use use a projection, because we want it to be always over the landscape. So use the landscape data from the tab, just reusing few nodes if I can, and then use the spline sampler so that it only spawns the spline on the spline this time. And the mode is supposed to be distance, and then use transform points. Let me just go ahead and add a static mesh spawner, and then under static mesh, under mesh entities, click on the plus sign. And now let me look for the content browser and look for something called fence. There you go. And then basically connect it to our static mesh, and there you go. Now we have our fence spawning inside our level. Let me just go ahead and click a few more additions to my static mesh. So let me just, because we have a few more fence, so I'm going to add the other one as well. Hit save, and now as you can see, the fences are spawning but in the wrong direction. So for that, I'm going to go under transform points and scroll all the way up where it says max rotation. I'm going to look for, wanted to face it 90 degrees. Yeah, 90 degrees, and then this side as well 90. Yeah, now all of them are facing the right direction of the spline. That's exactly what we want, by the way. So let's go ahead and change the distance, because there are too many of them. So we're just making sure that the distance between the fences are correct. It will take some time to tweak, because at times the pole might just overlap each other. So there you go. Now we have some nice fence. Perfect. This is exactly what we want. And the next step is gonna be, yeah, I'll just do this. Yeah, I'm kind of fine with that. Just a little, making sure that the spacing between the fence is not too much or not too less. Okay. Once I was happy with the position of the fences, I started placing it around a few houses. I also added a windmill and a small bridge. I added a few cameras, took a render out from Unreal, exported to DaVinci, color graded it there, and then the final output is something like this. So I hope you guys enjoyed it, because I know this was a pretty long tutorial and it could be really confusing when it comes to nodes. So I tried to explain it as simple as possible and try to keep it as simple as possible. And I hope you learned something from this video. And I hope now you are good to create your own little village out there. So let me know in the comments, or let me know in the reviews how you liked my teaching, and I'll be happy to help you out if you are stuck anywhere. So until then,